Hello everyone, welcome to the Kuma community call. Please add your name to the attendee list and feel free to put any agenda topic you'd like to discuss today. We don't have much from our side. To be honest, I would even prioritize some items like we have Daniil here from NSM. So maybe we can start with that, and then if we have time, we can discuss KDS redesign. Daniil, please.
Hello everyone. Could I share my screen, please?
Yeah, sure.
Okay, can you see the slide?
Yes.
Okay. Hello everyone. I'm Daniil from Xoret. I'm working on a multi-service mesh project, and this is a project about integrating NSM with other service meshes, and one of these meshes is Kuma. We have talked about our integration earlier. So if you don't know what this integration is, you can check out the previous the record of previous community call, which was September 14. So here's a link. Maybe you can copy it, retype it, or you can check out our integration example in the Kuma tools repository. So I'll give you a short reminder of what this is. So NSM is a service mesh that is based, it provides level 3 connectivity, so IP and stuff. And it is compatible with other service meshes. And in Kuma example, we are using virtual L3 network to provide connectivity with other clusters and virtual machines without using an ingress or anything like it. And here's a small diagram. So we, for example, we can have two clusters, both of which have NSM components. And on one cluster, we deploy Kuma control plane. And then we can, on another cluster, we can deploy some service which will have access to this control plane via virtual local network. And so one of our goals with the MSM project was to improve performance, because we, in theory, ingress components at some latency and maybe some other limitations. So in theory, this should improve performance, but we didn't have any numbers to compare. So currently we are working on actually running the tests. And here's our setup. Currently we are using, so far we have only run tests on using virtual kind clusters. And we have two setups, one with Kuma multi-zone. This is a very basic setup. It's just from documentation. With one exception, we are using Kuma control plane in universal mode because we don't have a spare third cluster or virtual machine. And in our integration setup, we just using basically the same setup as what is merged into Kuma tools repository. But in both cases, we're using different applications. We're using Nginx as a server which are testing against, and we are using Photo, which is a tool for testing HTTP connections. And I'll make it quick. We have found that in these virtual clusters, our solution is quite a bit faster. But before I go through the results, I would like to remind you that these are virtual clusters with next to zero network latency. So these results aren't really representative of real-world performance. So this is why I called it preliminary results in the title. But basically, well, I have had two examples. First is relatively low load, 100 queries per second, with just one thread. And here we see that average, not average, mean 50th percentile is 1.5 times lower with our integration. 90th percentile is about 2 times lower. And also we see max latency much lower. So Kuma is quite fast. It's just about a few milliseconds of delay, but our integration is faster. Well, then again, it's just virtual cluster, so we're still yet to test it using some production-grade clusters. Also, I have another example here with infinity target queries per second. So just how fast it can work. And here we see similar picture. I see that maximum latency with Kuma is the same, and I actually think it's not related to Kuma. It's something with Linux network system performance or maybe Kubernetes issues. But overall, it's a similar picture. It's about 2 times faster for 50th percentile, for 90th percentile, and about 1.5 times faster for 99.9th percentile. I expect that these results will get much less dramatic as soon as we move to production clusters where there will be network latency and maybe there will be difference in Linux network stack. But we see that there is some potential performance gains. So currently we are working on setting up testing using production grade clusters, like from Google, AWS, from Azure. Also, previous results don't really use proper statistical analysis. It just I read the results manually, see that they are kind of the same, and do math manually. So we are yet to do some proper statistical analysis and also better visualization. And so yeah, that's kind of it. Thank you for listening. And yeah, I would very much like to hear some feedback, thoughts, if it's useful, if it's if I have a good setup, or maybe I have missed something. Thank you.
Thank you, Daniil. Anyone has questions?
Is the source code to like replicate this test available somewhere?
We haven't published the scripts to set up it yet because we're still working on it. But yeah, we will publish it when we solve issues with public clusters.
Okay, sounds great.
Yeah, I have a question. When you checked Kuma multi-zone, did you use egress or it was just ingress?
It was just ingress.
Okay, so it probably will be worse with egress because it will be another hop.
yeah, I wanted to use some best case scenario for both platforms.
Yeah, and how do you have any interpretation, explanation of these results? Like, why do you think with NSM it's quicker?
NSM actually uses VPP program, which translates to vector packet processing, which is actually even faster than native Linux stack because it processes packets in batches. So yeah, I think this should be the main cause of such improvements.
Okay. Okay, do we have any other questions?
Yeah, I'd like to ask some more questions since I have the opportunity about improving our integration. So yeah, the first question is, could you think of some real life use cases that could be covered by our integration if we improve it somehow? Maybe add something to it?
Yeah, I think the main use case is when you want multi-cluster and you kind of choose between having Kuma multi-zone or having NSM plus Kuma standalone, right? So this is main use case.
Yeah, but maybe there's some issues with our integration that we can solve. Well, I guess this is not very good way to ask this question because you probably need to look at the code of the integration to answer it. But yeah, maybe you have something in mind.
Yeah. To be honest, I'd like to understand more how like the path of the request, like what's happening.
Yeah, if
so
you
maybe
have time, I can discuss it a bit. I don't think I have any good pictures with me, but I can just talk about it a bit. So on each node we have a forwarder and some forwarder which runs VPP, and when you start a pod which connects to NSM, forwarder establishes a connection between it and the pod. And so if we have a virtual network, then everything in this network is connected to forwarders on respective nodes. And in this virtual C, we run a virtual switch, which is also based on VPP, which creates which manages routing between pods. So when you create a pod which is connected to virtual C, you get pod with additional network interface, for example, 172.0.0.1, and another pod gets another interface with the same network, and the network prefix is configured using configuration of NSE. Which, by the way, NC stands for Network Service Endpoint. Sorry, I
So
didn't mention it.
essentially, you create like network overlay between two clusters, and in this overlay you run Kuma standalone, right?
Yeah. Providers connect to each other with some method, which is also specified in some settings. And so when you want to get service from different pod in the same Will3 network, the packet goes to forwarder on the same node. Then this forwarder sends it to Will3 then it sends to proper pod in the first cluster. Also probably through forwarder. And packets are processed using VPP.
Okay, yeah.
This might be hopefully this is a well-posed question, but like how does NSM compare to other like options for creating like an overlay network? Just curious, like what this, I guess, like the selling point or the advantage is. Yeah.
Well, I'm not a salesperson, but
Yeah, and that's what I mean.
I believe that the main selling point is that it is cloud native, so you deploy some pods, some deployments into each cluster. Then you just add annotation to pod, and Kubernetes manages the connection.
And at like a technical level, maybe like I guess VPP is a good example of the advantage of NSM, but I don't know if you have any other ones. Maybe like, yeah.
Well, yeah, you can. Obviously, you can use encryption, like with probably any other tools for virtual networks. There are also options to use other tools other from VPP. So we can use SRIV. If you have any SRIV enabled hardware, then you can use a special forwarder to manage it. You can also use Open Policy Agent security configuration, I believe it's called, to manage who can connect to where. So basically what NSM does is it manages VPP, and it manages all the management stuff to make it easy to use. I think it's kind of like this.
Okay, cool, thanks.
Yeah, it would be interesting to see the numbers on the real clusters when you have like clusters in different availability zones, for example.
Yeah.
In that case, probably the difference won't be that dramatic. So
yeah,
keep us.
Yeah, expect the difference will be much less, but yeah, it will be interesting to see if it matters, or maybe it's just 1%. Yeah, we're still working on it.
Yeah, thank you, Daniel.
Thanks.
Yeah. We have less than 10 minutes. Maybe we should, I don't know, maybe we should keep KDS redesign discussion on the next. I see. What do you think, Lucas? Should we discuss this now or maybe next time?
I feel free if we want to move to the next time. Depends if we have more questions from community.
Yeah, okay, that makes sense. Yeah, maybe then let's have questions. So, okay, yeah, anyone has any questions about Kuma? Yeah, I also didn't mention that since the last community call, we published a few releases, I guess 5 patch releases, mostly to update Envoy. And we had some minor issues with disabling IPv6 for the proxy. And that's pretty much it. So yeah, new releases are available. If we don't have any questions, then I think we can wrap this up. Everyone okay with that? Yeah, okay. Have a good day. See you next time. Bye.
Bye.
Thanks.
Bye, thanks.